Good morning, everyone. So we'll get started here. Presentation just for what we're going to go through today. Just note that we are recording the session, and the recordings will be provided to all of you after the knowledge sharing session today. So if you have to jump out for whatever reason for a meeting, you'll not lose anything. The knowledge share today is just a part of the Well Performance Consortium. It's one of 3 knowledge. So it's this first part right here in blue. So that's what we're doing today. We have a similar one that's also virtual in the end of Q2, and then we have WITCON, which is a hybrid option, so you can join both in person in Houston or online, and that's set for 19th of September. In addition to that, we have these half-day courses that's going through the end of the year. We have already done the one on PBT and phase behavior in Wits and Plus. There's now coming up one in end of April on bottom pressure calculations. There's one on RTA in June, one on flow material balance in August, nodal well test, and then we're ending with the DCA and type wall course in December. For those that are interested in joining WITCON in person, so all of you can, of course, join online, but in person, we have a limited number of people that we can accept there. So if you're interested in joining in person before we actually release this officially, just send an email to me. But for those that was at WITCON last year, you know what it's all about. It's basically a day of what we're going to do today virtually, and we're all gathered together in Houston. Last year we had around 150 people there, 80 plus different operators, and it was a lot of fun. I also wanted to spend just a very quick or take a very quick minute just to give everybody an update on the updated development roadmap for Wits and Plus. So this is basically starting from April, if you like. So one of the most important things, you'll see that in many of the presentations today, is that we've gotten more and more usage of the comparison plot feature. So we're actually doing a complete kind of re-ramp of that to make it faster, more robust, and adding a bunch of requested functionality, which I'm sure the whole community will appreciate. So feel, or at least be tuned or stay tuned on the updates related to that. One of the things we're going to look at today is a type well set that's being interpreted by 4 different interpreters. So that'll be a lot of fun. But literally in 2 weeks, the whole type well workflow will literally be 2 times or 2 orders of magnitude better, and then that's not a joke. So you'll be able to handle several thousands of wells just in the type well interface. So that'll be great. So stay tuned for a lot of upgrades related to DCA, auto forecast, and type well, which you'll see being presented on just after this presentation right here. We're continuing working on the multi-well numerical model. Tons of upgrades that we're working on there. The same goes, of course, on the RTA side to make sure it's getting more robust, and also now being able to auto fit it, a little bit similar to what Mo is going to show later, that we just released a auto fit function to the numerical model, where you can just go in and define parameters and automatically, quote unquote, history match a model within certain ranges. Then there's a good list of items related to just general usability. A couple of things that's been requested by many of you is to be able to have like a well hierarchy to the left, and then be able to sort that by pad name or county or whatever. So that's something we're working on together with kind of what we call consistent filtering. So right now you can set filtering in some of the features, but they're not kind of consistently carried throughout the whole workflow. So to be able to do that together with providing comments when you're seeing things, that's happening over time, etc., and such that you can actually look at how those things are changing when you're in different time functions too. For instance, material balance time, or linear superposition time, or real time. That is something we are working on together with an upgrade of the GIS. And then Graham will talk more about this later today, which is all the upgrades we're working on in kind of the nodal space, if you like, but being able to bulk run a lot of those activities at the same time as there. And I'll leave the rest of the updates to Graham in his presentation. So with that, I'm super excited about presenting the kind of the lineup for the first knowledge share. We got a lot of feedback last year. This is the third year we've kind of done these knowledge shares and gotten a lot of good feedback from them. And we try to make them very relevant using real data. And last year we got a lot of feedback that people really liked these 3 different engineers from different companies analyzing the same data set. So we're trying to kind of double down on that this year. So the first out, we're going to have 4 different interpreters on analyzing the same type wall data sets. They've been given 20 wells, and their goal is to provide a type wall for the oil and gas, so basically an EUR for that. And then I'll kind of summarize in a table at the end kind of the differences and similarities between the interpreters. And then we're going to have a little bit of case studies in between here before we end up with another kind of version of the 3 different interpreters on same data set, but that's going to be an RTA workflow. So first we're going to start with like type walls, so that's monthly data over time. And then it's an RTA workflow. The type wall kind of initiative and the focus of the company has been increased a lot just based on feedback from all of you clients. So we're kind of doubling down on that functionality to ensure that that's getting better and better. So before I'm introducing Kimberly as the first interpreter of that data set, I just wanted to introduce that problem first. So the problem statement is simple. We have 4 different interpreters that are provided the same data set to create a type wall. And you're supposed to create 2 type walls, one for the oil phase and one for the gas phase. And then you should normalize that to 10,000 feet lateral. And it should be also a total of 50 years of total production. But as you guys know, for me, the most important thing is not necessarily the number of digits in the answer. The most important thing for me is kind of the thought process. So make sure that you justify your thinking, just like my friend here to the right. And here you see a screenshot of the data set. It's an Anadarko Basin data set. So with that, I'm gonna stop sharing. And what was really cool about this was that yesterday I was sending kind of like a reminder to all the presenters to send me their presentations if it was lacking. And then Kimberly calls me. I'm like, what, are we supposed to provide a presentation? And then we just agreed that she's going to actually just do it live in the software. So that's it's going to be fun as well. So it's going to be kind of 3 in presentation format and 1 just using the software with Kimberly. So with that, I'll introduce Kimberly from Ayers Consulting, and she's going to be the first one out on the type wall exercise.
All right, hello everyone. Let me share my screen here. Well, here we go. I obviously didn't understand the assignment, but I love doing live demos here. I'll give you 2 seconds of background here to stay within my allotted 10 minutes. My background is in mathematics. My undergraduate degree is in math. So I love that we're applying statistical analysis to type wells now. Love it. And my master's degree is in petroleum engineering. I'm based in the Appalachian Basin, so I'm a specialist in the Marcellus and Utica. It's fun that this well data set is not in the Appalachian Basin, so I'm going to be approaching this from a really general perspective. And I'm going to walk you through what I would do if a client sent me this well set and said, give us a type well as fast as you can. You're going to hear me stating, as a good reservoir engineer does, a lot of exceptions and some items I would go back in detail if I had the time to do so. But the request is to do this quickly and get a efficient and accurate answer. All right, so first here is our well listing. What I like to do first is I don't know anything about this set other than it's not in the Appalachian Basin. I like to cheat here a little bit and go over to the Edit All button so that I can pull up all of my well data and see where it is. Located in the Woodford. Cool, that's fun for me. And I like to look at my completion parameters and see if they're generally within the same range or if I'm going to have to account for that as I build my type well. The lateral lengths are all pretty similar here, so we're not going to see a huge variation in IPs probably, but I will normalize for that as requested. The next thing I like to do is I like to do a quick peruse of my production data. So I like to just flip through the wells real quickly and see if we've got any big gaps in production. I need to understand if I want to normalize to initial rate. if I need to normalize to producing time by product, and just be careful of any large breaks in production. So here we go, just flipping through. All of the production seems pretty consistent. I got a couple wells with some downtime here, something going on. So just want to be cognizant of that. The data set's pretty clean. The next thing I like to do is to jump into comparison plot really quickly. And I just want to see this initial plot here, gets a sense of when wells are coming online. I've got a big set in 2016 or 2015. Well set in beginning of 2017. This is not normalized and the production's pretty similar. Don't have any large outliers. So now I'm going to jump over into type well. Oh, actually, I'm going to first go over to auto forecast. In case I need an auto forecast, I'm going to go ahead and start the process. I don't always append my DCA curves when I'm doing type wells. It depends on the length of time, completion types, the large variation in data. It depends on if I'm going to append DCA or not, but I like to go ahead and get it started. One of the questions Matthias asked us to address was what our bounds are for D min, B factors, initial rates. If I'm in an area I'm very familiar with, I'm pretty restrictive on my B factors. This is Woodford. I'm not familiar with Woodford, so I'm going to leave the B factor pretty broad. 0.6, 1.8 is a little too high. I'll probably pull that down to 1.4. That is just experience-based. I like to go with a 5% or a 6% D-min, depending on what the application is. If I'm doing an external look for A&D, want to be a little more conservative. If I am doing reserves, also a little more conservative. Sell side, maybe 6%, 5% I mean. So just depends on what the objective of the analysis is. So what's in super fast, small set of wells, pull in my wells, run the autofit. I'm not going to run it because I already did this for you guys and saved it out. But I do like to have that in case I need it. Next, we'll jump into type well. All right, so now I see where my wells are. I have my probit plot down here, and I like to start with the probit plot to get a sense of the spread of my data. So it looks like we've got a I would consider a pretty tight band of IPs here. Got a couple outliers, of peak rates. Got a couple outliers, not too bad though. And I also like to take a look at IP90 to see where we end up with. I generally am working with very dirty conventional data, older production. This is, for me, a very clean data set in my experience. From there, I like to go ahead, get a better look at my data. We've got all of our wells selected here. I like to be in normalized time first. I do prefer the geometric mean. If you read in the help, there's explanations between the geometric and the arithmetic. I like geometric from a mathematics perspective. I do also like to turn on P50. I like to compare where average and P50 are on the rate graph and the cumulative graph. This tells me about the size of my data set. When we go back and look at the log, consistently reliable data set should have a log normal distribution. You can compare that with the average and the P50. So I like to get a sense of that. This case I'm going to be presenting, I'm going to fit on the average because I want to be more conservative. Now, if this analysis were being used for cash flow or economics, I would want to be really careful with this early time right here. Take into account the first 2 months of ramp up of production. In this particular case, I'm more concerned about EURs. I am going to go back and I'm going to normalize everything to peak rate because I'm more concerned about an EUR in this situation, and it cleans things up a bit. And am normalizing to lateral length. I've got it set to 10,000 feet. And like I said, I'm going to go with normalized time first, even though there was some break in the data. It's just a little bit more easy and clean. So let's reset our zoom here. Just taking a look at our data, we've got, basically 2 sets of data. I like to look at the cumulative as well. Kind of a spread here in my P50 and my average. All right, I feel like I understand the data well enough. It's set up how I want it to be. I'm going to jump into DCA and do a fit, making sure my type curve is an average for this particular case. Again, I usually use P50 or the average depending on the data set. We're going to do one segment here. One of the things I like to do is lock the start day at 30 days. The autofit seems to do better when I do that. I'm going to click autofit. Don't really like the shape of my curve here. So I've got my autofit locked. Initial rate at 670. That's the next parameter I like to get locked in. So generally I'll go back to my type curve here. I will pull up the probit plot. Oops, do not want that. I want to collapse that, pull up my probit plot, look at my IP30, see about where it is on the P50. So, somewhere in here, right? And then I'll look into that data a little bit closer and lock in my IP rate. It feels a bit low at the moment, so I'm going to move it up to 675, and then I'm going to lock that in. I'm going to ask it to autofit again. Moved it a little bit. Don't like my shape very much, so I'm going to change the B factor here just to see what that does. That shape seems a little bit better. Now I'm going to, I must have had my B factor locked a second ago. I did. We'll have it fit again. Oh, drop me down to 0.8, 0.8. This is, I'm living dangerously here, doing this live. Hit the wrong button. All right, and we're back. 650. Let's go with a 0.9, just see what we got here. I like that a bit better, and I'm going to change my decline percentage down a little bit, see how far up that pushes us. Don't like that as much. Go to 83, went the wrong direction. And again, my IP feels a little low, so let's go to 670. That's all right. Maybe a 0.8 here. So it's a little bit of an iterative process. Move this up, do that. Oh, I like that fit very well. All right, I'm going to set this to 5%, and then I'm going to save the case. I did this previously. Let's see where we end up with my previous fit. Oh, I was a lot higher. Last time I did this, I also did not normalize to peak rate. I'm almost out of time, so I'm going to jump back over and look at this on the wells. I love to see it, where my wells are. Zoom this back in. There's the previous fit I did. Now, I mentioned sometimes I like to append my DCA. I also did the same process with an appended DCA here. I did want to say when I appended DCA, my curve was much higher. The delta makes me pretty uncomfortable. This tells me I need to go back and probably clean up the individual wells DCA curves, get more comfortable with that B factor to change the delta here. Now, when I switch over, and I really like to look at these on the cumulative, that cumulative band, it really makes me uncomfortable. These are too high to the average when I align to peak rate. Again, when I did these, I did not align to peak rate. I wanted you guys to see that difference. So this tells me I need to go back, do some detail work, maybe consider completions, do some normalization on completions. Let's look at gas real quick as I'm running out of time here. I did the same thing with gas. So there is my curve that I fit with gas. Looks great over the average. Again, the P50 is a little higher, which makes me a bit uncomfortable. But then my appended type curve, DCA appended type curve is basically similar. So it tells me the gas curve is fine. I don't need to spend time going back. For me, all of this is about being accurate, but also efficiently using my time, saving dollars for my clients. So I like to do the scoping first before I go back and really dig into the wells. Let me just put this appended DCA on here so you guys can see what the curves look like. All right, I think there's my 10 minutes. Hope that was helpful.
That was great. So now the people, this is really impressive. So, the thing, Kimberly, is that you do the demos better than I do, and anyone at Whitson. So it's for everybody seen me do the demo, they were like, oh, this is so much better. So anyways, it's good to see how good it can be. And I noted down your EURs here, and I'll pull that up in the summary table a little bit later. We're going to just continue to jump ahead, and thank you so much, Kimberly. This was awesome.